So let's take a look at the results of the second Twitter poll somewhere. Or I'll just announce them. How's that? So it looks like Rob Baker's presentation on Brick was the winner for the second Twitter poll. Either that or he just has the most Twitterati friends. So we'll go with the first. And now for our afternoon keynote speaker, which you all came back here for. Mark Ryland, I'm proud to introduce, is the technology leader at Amazon Web Services' worldwide public sector team. Mr. Ryland leads a team of solutions architects and professional services engineers who provide AWS technical evangelism, architectural guidance, knowledge transfer, and implementation services to government and education customers around the globe. He has served as CTO of 2 startup companies, as well as vice president and director of the Washington, D.C. office of a Seattle-based public policy think tank. So please join me in welcoming Mr. Mark Ryland.
Thanks, everybody. Thanks for coming back this afternoon. It's a real pleasure to be here and talk about a topic that's very interesting and very near and dear to my heart and to the hearts of the folks that I work with at Amazon Web Services. So I want to start off by saying that I'm going to do this presentation in sort of 3 phases. I think in the first I'll try to talk about sort of the generic trends around mobile and kind of expand that, as I think your conference has, to sort of Internet of Things topics. I'm going to talk a little bit, I can't help it, a little bit in the middle about Amazon Web Services. In fact, throughout this, of course, I'll be using examples and so forth. I'm trying not to make a sales pitch here, but this is what I know, so I'll certainly talk a lot about Amazon Web Services. But of course, much of what I say can be abstracted and be treated as sort of a general comment on a big industry, mega trend around the shift towards utility-style cloud computing. And then at the end, if I have time, I want to go into some pretty detailed sort of summaries, actually walk through some short slide decks of a couple of our customers, because the customer use cases are always the best part of these discussions. What are people actually doing in these large-scale systems and doing with mobile and Internet of Things? So that's the theme of my talk, is mobile and smart devices powered by the cloud. So smart devices, right? Well, we can at least say that they're devices. How smart are they? And of course, there's a huge variety of answers to that, but it's everything from things, little microcontrollers and refrigerators, to wristband devices. A couple of these little ones on the left are these programmable machines. I'll talk a little bit more about the details that people are using as they build new systems. How smart are they? Let's look at a couple. Arduino, this Arduino Uno, very popular platform for very low power computing devices. So it's got about the power of like an old, Osborne or K-Pro from 20 years ago. So 8-bit CPU, 20 megahertz, a little bit of memory, a little bit of storage. You can still do some very impressive things on a system like this, but it's very limited in power. And there's going to be billions of these things out there. Already are many hundreds of millions. Kind of at the upper end of the scale, how many of you know about a Raspberry Pi? Raise your hand if you know about. Yeah, okay, good. They've got some good momentum and good marketing. Everybody knows about Raspberry Pi. This is essentially a Linux box, a Android box on a chip with Ethernet jack and a USB cable jack, and that's about it. And it's powered by a fairly powerful ARM processor, 32-bit, with a decent amount of memory and storage of your choice with an SSD card, so you can have many gigabytes of storage. That's kind of, these two kind of define the range of the spectrum of devices that are out there when we talk about smart devices. What are these devices? They range, think of them as just every kind of input or sensory device. Cameras, probably many of us have a lot of these, maybe even right now with us in our pockets. So GPS devices, different kinds of gyroscopes and sensors of motion sensors, all the kinds of motors, all the way from tiny little things to General Electric, building these sensors into their very large turbines and their jet engines. Every kind of, you can sort of think of these as like the sensory, the 5 senses, if you will, of the machine age. Thermometers, accelerometers, propellers, every kind of device that we used to build and think of as just sort of a functional thing. Now, more and more, those things have not only some kind of output, they have the ability to actually receive input and perhaps put that input back into a larger system. Here's a great smart device, right? the refrigerator. There are a lot of refrigerators now in the market that are internet connected. They have lots of intelligence to them. They can do things like scan or RFID your groceries as they go in and out. They can be you can do remote maintenance on these things, do troubleshooting remotely. Really, really powerful. That isn't too surprising. I think a little more surprising might be we actually have smart trash cans. So these things can do all kinds of interesting things. Again, around RFIDs, they can make some judgments about sort of volume of waste, type of waste. Very, very interesting as the market develops. What else have we got? This is, I'll put in I'm a little out of step, I'll put in an Amazon plug. So how many people have ever seen Amazon Fresh or used Amazon Fresh? So that's a grocery delivery business that Amazon is rolling out fairly slowly on kind of a city-by-city basis. It's not a very easy business to develop, on a large scale quickly. Coming to a city near you. As an adjunct to that service, there's this wanded device which allows you to do essentially automatic ordering by barcodes or RFIDs. So now as you're going through your kitchen, you want a couple more of something, you just scan the thing. It'll place that into your shopping basket. You can also speak into this device, and it'll recognize your phrases. Say I need to buy, 5 pounds of flour. That'll also be interpreted and smart added. I don't know if anybody's used a Fire TV yet, but Fire TV also has a voice control system that's quite sophisticated. It's all cloud powered, so the device simply does some initial processing, uploads the voice to the cloud, and there's a very powerful cluster of servers that can then do recognition and almost, what experience you experience it is, so it's a real-time response. And that same type of technology powers these little wanded devices. And again, this is something that you'll see more and more of as time goes by. Other products out there, things like weight control, exercise. How many people have the little wristbands? Raise your hand if you've got on a little wristband. You have people out in the audience that are measuring your activity, giving you some feedback on your physical exertion. Often those things will be coupled with smartphone apps, which enable you to get a time-bounded and time view graph of what's going on in your personal environment. Smart toothbrushes. How many people have seen smart toothbrushes? These are pretty cool. They'll give you all kinds of data about your toothbrushing habits, how often you do it, how vigorous you are, and lots of other cool things. Let's keep going. Now, this is, again, a little bit more near and dear to my heart. Dropcam is a company that actually was founded and really grew dramatically running on Amazon Web Services. Dropcam, anybody heard of Dropcam? Raise your hand. Anybody have a Dropcam? Let's see if anybody, yeah, good. Got some customers out there. This is essentially, again, a great example of an internet-powered device. So you put this video camera into your environment. It can act for a variety of things. It can be sort of like an equivalent of a surveillance camera. It can be for making sure pets are okay. It can be for sort of checking up on environments where you aren't present. Dropcam, with permission of their customers, also has this amazing sort of blooper collection because since the cameras are running all the time in people's homes or offices, they often get some really crazy, funny things that happen. And again, they allow people to post those to kind of a crowdsourced environment. So if you want to go see some really crazy, funny things that sometimes happen when the cameras are running, you can do that. Let's take just a quick look behind the scenes. So this smart little device using Wi-Fi or a wired internet connection. What's happening in the background? This is the sort of chart of their growth over time and essentially how it's just gone absolutely vertical in the last couple years. This is the largest inbound video service on the web today. I'm getting a little cut off, I guess. I'm sorry, my slide here. More than YouTube uploads, so petabytes of data. This is all powered by the cloud, by the AWS cloud. And again, the beauty of this type of environment is when they launched this system, they had to develop really nice little devices, but they didn't have to worry about that massive back-end infrastructure. They didn't have to spend the capital expense or take the risk of buying the capital, spending capital on equipment, on servers and storage. And simply, as the demands increased, they simply just kept turning it up. They just turned the knob. So now they spend a fair amount of money on infrastructure, but they spend exactly on what they need and what they use, and they don't have to make upfront investments in that, and they don't have to guess about what their capacity is, and the usual problems of you over-provision or you under-provision and all the things that tend to arise from that. Here's some other good examples. Vitality is a company that's doing some really interesting things with medication and sort of augmenting the experience of taking medication. One of the things that all doctors know is that people are not very good about taking their meds. They struggle to be regular. They struggle to to follow the exact regimes they're supposed to follow. These devices will begin to do things like personal reminders. You can set it up to coordinate, so a caregiver or an adult child or something can now be sort of part of the experience and know how you're doing in terms of your using of your medication. The sort of bottom line result is that if you look at things like this chart, which shows essentially missed days over a period of time, this would be like a before example, and this is what poor adherence looks like. After beginning to use the smart devices, you start to see patterns more like that. So you see a really, really big improvement in the quality of the medical regime that people are able to operate within, and concomitantly good health results. Here's a great info bit. When you think about birth of a child and all of the video, all of the pictures being taken, and all that data being generated, it's a massive amount of data. It's equivalent to thousands and thousands and hundreds of thousands of books in terms of the amount of storage required to process that. And again, this data explosion is going on all around us with these smart devices, and the need, therefore, for some kind of back-end storage and processing. So the challenges, I think, are pretty obvious. Thousands, millions of devices producing tons and tons of data all the time. What do we do with it? We also have a ton of potential uses of that data, so all kinds of back-end potential uses, so results of that data, and you really need something in the middle to deal with these kind of challenges. And it has to be a distributed system. There's no single computer or giant mainframe or anything, and certainly no networks that would enable all this stuff to be sort of aggregated into a single place, processed, and then spread out again. You're going to have to go to distributed processing models and to use very large-scale systems, but horizontally scaled systems in order to deal with this onslaught. Of course, scale is a huge factor here, and I'll talk a little bit more about cloud scale in a minute, but you need something, you need a new technology base that allows you to scale very, very expansively. So, of course, what's my answer? Cloud computing. Now, let's be very clear. When I say cloud, I have a very specific meaning. Those of you in the IT industry know that the term cloud has become so pervasive, it's used for every product that you can imagine, right? In fact, the industry analysts have a term for this. They call it cloud washing. So you have a product, and you want to sell more of it. You somehow associate the word cloud with that product. You put it on there somehow. I've been on metros down in DC, or here in DC, and I look up on the wall and I see cloud servers from a traditional vendor. It's like a picture of like a server in a rack. It's like, it's a cloud server. I'm looking at it like, it's just a server. I mean, what does that have to do? I mean, I suppose you could build a cloud from such a thing, but you could always do that. There's nothing special about that. But anyway, so when I say cloud, I mean something very specific. I mean large-scale, utility-style computing, pay-as-you-go, the experience of limitless capacity. It's not actually limitless, but you experience it as limitless because it's so big that any given consumer doesn't ever hit those limits. You don't experience it as being a constrained environment. If you have those characteristics, accessible over the internet, pay as you go, and when I say what I mean by that very specifically is pay by the hour, pay by the gigabyte. I mean small increments, not pay by the 3-year period, and pay for what you use, and have access to this kind of very generic, powerful processing based on the open and de facto standards that have emerged in the industry, the TCP/IP protocols, the Linux and Windows operating systems, all these things have just become completely generic and very powerful and capable of running really amazing workloads. And if you just build systems with a whole lot of those things and a way for users to interact with them and self-provision and self-manage, you can build a true cloud. So again, the experience that you have when you utilize these systems is one of a limitless experience. So to power this, we've seen this slide. We need the brain. So think of the cloud as the brain. So you've seen this slide, which is all the sensors. We need something in the middle to actually accept all those inputs and do that core processing. And I postulate for you, and I assert that more and more you'll find that the answer to these problems will be these large-scale utility-style computing systems, of which Amazon is one exemplar, but there'll be others. I won't say there'll be many others. There'll be others, and I say that because it's a scale game, and so it's kind of naturally concentrated industry. It's very difficult for you to have hundreds of people with super, super large, internationally scaled systems. So there'll be a small number of players, but it'll be a highly competitive industry, and already is a highly competitive industry, with prices dropping all the time rather than going up, as we experience in the history of IT. So it's a very big shift in the industry. So let's talk a little bit now about Amazon specifically. First of all, how did Amazon get into the cloud computing business, right? Very natural question. So let's see if I can answer that for you in a few minutes here. At its heart, Amazon is a technology company. It's really, it has a lot of physical stuff. It has distribution centers and people moving packages around, and it's managing fleets of, of delivery vehicles and things like that. But the reason that all can work, and the reason it can get more and more efficient over time, is because technology at the core, making those processes, those systems, those physical things more and more efficient. And to do that, you need lots of software and lots of smart software engineers, and you have to build a lot of systems. About 10 years ago, in the lifetime of this company, well, a couple things happened. First of all, in the late 1990s, Amazon, the e-commerce platform, it ran on a few very large systems, right? So those of you who are in the IT industry, you'll remember the DEC Alpha machines, one of the first 64-bit machines. It was kind of like a Unix mainframe, and you could buy really, really powerful DEC Alpha machines, and they could run a ton of processing, and they were just wonderful. So like a lot of users of that era, Amazon said, okay, fine, we're going to get like a big hunkin' relational database, we're going to put it on this machine, and we're going to get like this web server thingy, we're going to put it on this machine. And we're just going to buy these really powerful machines, and it's just going to work great. And so it kind of does. It works great for a while. And then the next year comes along, and you're doing twice as much traffic, and you're like, oh, darn, it's not running so fast anymore. Buy a bigger machine. Okay, so you call up your supplier. Okay, you got a bigger one? Yeah, we got a bigger one. Okay, send the bigger one. So they send you a bigger one, and you move your software, switch over. It's like, okay, we're good. Got a little more headroom here. Next year goes by. You see the pattern, right? And the problem is there's no way that you can run these large e-commerce platforms on a small number of machines. You have to shift your architecture and your whole mindset to a horizontal distribution of processing. So a very large number of smaller systems doing work in parallel can power these very large-scale systems, but you can't do it with bigger and bigger systems. So that first step is key to the second part, which you might we'll see the relevance, because now you're managing thousands of servers, right? If you go to a horizontally scaled out system, you've got thousands of servers. Used to be you had a couple, very powerful ones. Now you've got thousands. What do you do with those? Well, they become a management headache, and they become a procurement headache, and they become a resource headache. The software developers that you pay top dollar to, and you want to be spending all their time writing application code, great new features, they start managing infrastructure. They start ordering servers, and they say, I want to build a new system, and I got to buy some more servers because I can't run it on the production platform. So I've got my maybe dev and QA and test platform for my existing part of my app, but I need to do a new thing. So I buy more servers. I buy a rack of servers, and I start writing new code, and maybe it doesn't go well. First of all, I get in trouble because I just spent all this CapEx on experimentation, basically. But that's probably okay in a fast-growing internet company. They're not going to fire you for wasting some money on servers. But what's the next thing you do? You hide the servers. You don't give them back into a common pool. Why? They're so hard to get. So you have a lot of this very natural but sort of bad behavior, which is hoarding of physical things, because getting them is so difficult. So the senior managers at Amazon realize this is, at its heart, it's a software engineering company. We don't want our software engineers managing infrastructure. We want them to be writing application code. So what can we do about it? Well, some people had a very bright idea. Why don't we turn infrastructure into a service? Why don't we take all the stuff involved with building and racking and stacking and managing physical infrastructure and all the core things around operating systems and lots of other things, load balancers and database servers, all that stuff, turn that into like a product that you can get very easily through an automated interface. So call an API, get a server. Call an API, get a database. When you're done with it, kill it. It doesn't literally go away, but you're not being charged for it anymore, and you can move on. So now you can experiment, you can move much more faster, you can drive a more agile business model and so forth. So ultimately, it was this experience as a very large-scale software engineering company that really drove Amazon to see the business value of this generic platform, infrastructure as a service. And it's been a wildly successful business for Amazon, growing by leaps and bounds. And the reason is because everybody else in the world is doing exactly the same thing. Everybody's doing exactly the same thing. They're buying data centers. They're getting internet contracts. They're getting power contracts. They're buying servers. They're racking and stacking the servers. They're deploying their networks and their IP blocks and all the stuff that goes into running, data centers. Everybody's doing the same thing. And that's the point. It's undifferentiated. There's no value. There's nothing special about it. It's the same thing everybody else is doing, so therefore it has low value. But it's hard. So something that is low value and hard is not a good combination. So having somebody take care of that thing for you and do it cheaply and at high scale and high efficiency is at the core of this revolution that you see going on around you, which is the move to this utility-style cloud computing. Just to give you a perspective on scale, so let's back up the clock to that 10 years ago when Amazon is a very large company, $7 billion in revenue, 8,000 employees, lots and lots of computing capacity driving its internet e-commerce platform. Today, on a daily basis, Amazon Web Services adds that much computing power to our fleet around the world. Every single day. That's our growth rate. And I'll come back a year from now, it'll be an even bigger number because it's going up exponentially. Here's another perspective on scaling, storage. So S3 was one of our very first services. It's a web addressable storage system. It's called Simple Storage Service for a reason. It's a very simple API. Get, put, a couple other little things. The total API surface of this thing is about 10 APIs, maybe 12. But we thought, developers will think this is useful. You can just stick an object there. It's got a lot of security features, so you can lock it down as much as you want, or you can open it up as much as you want. And when you need it, you retrieve it, and it kind of fits into the web model of how to build systems. And so we put it out there, and we were really happy when we had, about 18 months later, we had 14 billion objects were stored in S3, and we thought, man, this is really an awesome system. People love it, very successful. Well, as you can see, what happened as the years went by, things went crazy. So now we're up well over 3 trillion objects under storage, massive amounts of storage. The system, it never goes down. It's available 7/24, super high durability promises and high availability promises. That is, it's designed, it makes many, many replicas of your data. So if you do a put operation into this scaled out storage system, which by the way runs in multiple data centers in a given thing called a region, when the success value returns, you get a 200 error code or 200 success code from an HTTP protocol, and you've put your object into S3. By the time you get that, S3 has replicated the bits that you sent. First of all, it's encoded them in a special way so that if we get bit rot, you can recover. So that if you lose some data, it can recover even one copy. And it's made multiple replicas across multiple data centers. And so you have a really, really high durability promise around that service. And I go into some of those details just to give you a sense of what this is not like just like a local network storage device in your data center. It's a very, very scaled out large scale system, and it's turned out to be super useful and been really successful. Global infrastructure. So one of the things that we do as we build these systems is we build lots of these regions around the world, 10 regions now and growing. There'll be many more coming in the coming years. Right now, 4 in the United States, including a special region that's near and dear to my heart since I work in the public sector team. We have a region called GovCloud, which is specifically designed to meet some US federal government requirements. But it's 99% the same as our commercial region, same APIs, same features, with a few tweaks. And in general, that's the key to this thing, is that all of these regions, although they're all kind of separate clouds, and you can think of it as a federation of clouds. The reason the regional concept is so important is because it gives you data locality. So we don't do any automatic replication across these regions. We have features that'll let you do that, but we don't do it. So if you put your data into our Dublin region, it doesn't go anywhere. It's there. So if you're constrained by European data protection rules, no problem. They'll be met there. We don't replicate. Similarly, in the US, we have a lot of government customers that have rules around, hey, our data has to stay inside the boundaries of the United States. And so, again, use the cloud in that fashion. We have a lot of customers in Singapore. Singapore government is a very big customer of ours and growing very rapidly. And so there happens to be a region there in Singapore, and so they're very happy about that. They have data locality. But a region is not just a data center, it's multiple data centers. It's a cluster of data centers. There's at least 3 in every region, and sometimes many more. And those then give you the redundancy and the reliability that you need. And they're designed very carefully to minimize any type of possibility of correlated failure. So the state of the art of the industry, for better or for worse, is that occasionally you'll get data center level outages. Power goes down, fine, you have your generators are running fine. Maybe something goes wrong with the generator. Sometimes little weird things like $40 programmable device that decides whether the power coming from the generator is good enough or not will not kick in, even though it really should have. So there's a lot of failure modes, unfortunately, at the data center level. Even though those are rare, they do happen. So in light of that, we build these data centers such that they don't fail at the same time. And if you if you distribute your workloads across them, then you can have highly available systems that never go down, even when there's an outage at a particular data center for whatever, 5 minutes or an hour, whatever it may be. You can basically get nonstop computing. So that's a big part of what we provide. So here's, switching now from kind of the global picture to the local picture. What are the kinds of things that you need to do? I'll just go ahead and click through this slide. The kinds of things you need to do when you build a mobile application, or you can, by extension, think of this for any type of device type of system. You got to do things like you have to authenticate users, manage their identities. Not always, but generally you want some kind of security capability there so you can decide who's authorized to do things as well. Synchronization, data synchronization is a very common requirement because sometimes the devices are connected, sometimes they're not, so you need to be able to get data back and forth. You as the entity writing the application, you want to analyze user behavior, so you want things like how often was the app running, how engaged was the user in terms of clicks and so forth. You also want to track at a higher level how, whether users stay with you over time, how long they use the app when they delete it. All that kind of stuff is really, really valuable. And then kind of the storing and sharing of user data is also a very typical scenario. So there's a lot of things here. And just want to highlight one thing. Push notifications, really, really important and actually somewhat difficult to do in the mobile space. The reason is because mobile devices, you don't really want to run a process in the background because that kills the battery. So all of the mobile operating system developers have developed relatively complex ways that they can occasionally check for messages, deliver those to applications. That's why you get the little red dot on your screen or whatever that says there's something new here. On a traditional computer, you just run a background thread and you check yourself, but in mobile phones, that would just kill the battery. So they have developed these somewhat elaborate and somewhat complicated methods by which you get these things called push notifications. And not only are they a little bit complicated when your code running on the device, but the backends are also a bit complicated as well. So you really want something to just take care of that for you, make it really simple. As just one example of many, many things here. So we have services in these areas, you wouldn't, unsurprisingly. So we have things like a Cognito, which is our identity system for mobile applications. We have a very rich authorization and access platform where you can write very precise policies about exactly what a user can do from when they're touching a backend service, all the way down to like the row level in a database. You can literally have a policy that says this user can only update these rows or even these columns in a database directly from the device. That's another theme here for the more technically minded. There's a trend away from three-tier architecture where you have a client or like a web browser application tier and a sort of service tier to two-tier applications. So a lot of our services are directly addressable in a secure way from mobile devices, for example, or web browsers. So that simplifies your life a lot if you don't have to run a fleet of middle-tier servers. You may still have to run a few, but a lot of things the device can talk directly to the data storage platform, whatever that may be, whether it's a streaming service to accept inbound messages at a high rate, whether it's a NoSQL database or a key value store like S3, the one I mentioned earlier. These are all things that you can call directly from the code running on the device, whether it's a mobile device or Internet of Things type of device. And these same kind of principles apply for the Internet of Things scenarios. So they're going to be very useful as you build these systems out. So again, you really want to be able to take all the inputs coming from thousands, millions, billions of devices on the one side, think about all the outputs and run those at scale. And to do that, again, you need a lot of processing power. So just to concentrate for just 1 minute on one of our core services, we have a lot of other services that are higher level where you can essentially just get a lot of function with calling a simple APIs, but at its heart, a lot of people still need to write their own code, applications that they write on a platform, so Linux applications, Windows, what have you, Java application, they run their own custom code. And so what we do for that type of scenario is we have a virtual machine service, a service where you say, give me an operating system, and I want to use it, and then when I'm done, I'll shut it down. And that core service for us we call Elastic Compute Cloud, EC2. So in that core service, you can literally obtain, thousands of servers and run them for a short amount of time and pay the same price as if you took one server for thousands of hours. So 1,000 servers for an hour is the same cost as one server for 1,000 hours, because you pay by the hour. So with that type of capability, you can start with the server as loads grow, and we even have auto-scaling technologies that allow the systems to automatically increase the number of servers as depending on load. You can scale that to thousands of servers, and they can all be doing parallel work. And then when the work is done, you essentially either automatically or manually, you scale back down to one. And if you don't need the one, you can just turn the whole thing off. So it's basically, this is literally infrastructure like as simple as a light switch. So you just kind of say, I want some server, I want it off, on and off, and you pay for what you're using. So it's a very powerful model and a very revolutionary way of doing IT. Now, I can't talk about cloud without talking briefly about security. I would love to talk for a long time about security. In fact, I give a lot more talks on security than I do on mobile and Internet of Things, so that's more of a specialty for me. But I will say this, and if you ask me back to the next session, if you want to talk about security, I want to make the case that you can build more secure systems in the cloud than you've ever been able to build in traditional infrastructure. And maybe that sounds like vendor overpromise, underdeliver kind of thing, but believe me, I think I can persuade you, and I can also bring in customers. That's more importantly who will say that they have that same experience. It's not a panacea. You still have to build, there's still responsibilities that you need to shoulder. You need to do your job right. But the beauty of it is there's a lot less you have to do. The surface area that you have to be worried about is much smaller, and you can concentrate your efforts for building secure systems on a much smaller problem than if you're running the entire infrastructure soup to nuts. So in a nutshell, again, I have like a 1-hour talk I give on this topic, the 6 reasons why cloud enables more secure applications. And you go into each one of these in detail, but in essence, you see them up there. So we focus a lot on making compliance real. So in the past, when people talk about compliance, it was more like there's an auditor checklist you kind of go through every 3 years. Yeah, password length, whatever. And then 3 years later, they come back. In the meantime, systems are hacked, right? I mean, there wasn't a tight binding between the people whose job it was to sort of see, are you in compliance, versus the people who sort of operationalize security. In a cloud system, those two are very, very tightly bound together. Literally, within our group, there's under one chief security officer, there are 2 teams, the security assurance, which is the compliance team, and the security team, and they're married at the hip, and they work very closely together. And one of the key reasons there is because cloud is a new kind of abstraction, and you don't get to know some of the low-level details. Like for example, if you come up to us and say, look, I want to run this really important application on your platform. It's, super critical government system. I want to tour your data center. Sorry, you can't. Well, what do you mean? I mean, I'm a big deal. I'm this government agency. I'm the head of the department. I've got this important application. It has to be super secure. I want to have my own experts come around and look around and poke around. Sorry, you can't do that. Well, why not? Well, just imagine that all of our customers asked to do that. First of all, how would we differentiate them? And even if we said 10% could do that, what would our data centers be but a big circus parade of people going through and poking around? It would be very, very, very insecure to do that. Now, on the other hand, the customer then says, well, that's crazy. You're a vendor. Why should I trust you? Right? I've worked with vendors before. I don't trust them. And we say, you're right, that doesn't make sense, actually. I mean, we understand your point of view. So what's the solution there? The solution is expert third-party auditors who essentially work on your behalf and check up on us, but they're relatively small in quantity. There's a lot of them. There's multiple audit teams that constantly are in our environment. But those folks will do that testing and do the checking and the pen testing and the physical stuff and all the biometrics. They do that regularly. They write reports, they create evidence, thousands of pages. For those of you who are federal customers, you've probably heard of something called FedRAMP, right? We have a FedRAMP ATO, and the documentation for our FedRAMP ATO measures in the thousands and thousands of pages. Even the summary documents are hundreds of pages. We've had customers that have run federal data centers where they're a bit skeptical about the cloud, and they say, okay, I'm going to go look at that FedRAMP documentation. They come back, and they say, you know what? I stopped after like 5 hours of looking. I mean, there's no way I could run this data center as securely as you guys do. I mean, this is your lifeblood. It is our lifeblood. It's a business depends fundamentally on running a secure platform. Without that, we have nothing. So compliance becomes very important. Economies of scale apply. For every security engineer I hire, and I have a lot of them, we have a lot of them in our company, Their number of servers that they're responsible for is vast because they can do them in this very utility-style automated scale-out fashion. So you get a lot of economies of scale from these large-scale systems in the area of security. Customers refocus on systems and applications. I've already made that point. Things you worry about shrink. We worry about a lot of stuff that you used to worry about. You worry about less, but you then can do more to a better job on those things. The other ones, so homogeneity. So the cloud has got a ton of features, and we have all these different server types, whatever, but what it doesn't have this 20-year legacy of just stuff that you have in traditional environments, which are very difficult to manage, difficult to understand, difficult to know what you have. Visibility, think about that. So, you go to a data center operator and say, okay, what is exactly in this environment? I want a detailed list of every device in your environment. Most people can't give you that. They might have some configuration management software that has a pretty good idea, but they can't really tell you that. In the cloud, we know exactly what you have. In fact, we bill you for it every week, right? Every month. So we really care a lot about them. They're not being like hidden servers somewhere. So the automation, the scale of the system is all built around the visibility, the relative homogeneity. There's not a huge variety of equipment. It's more kind of narrowed down to the 80-20 rule. You can do 80% of what you want with a 20% of the variety. And the automation itself, the fact that it can be all API driven, makes it really, it enables some very good secure practices and so forth. So I won't go into the rest of these. I've spent enough time on this part of it, definitely in sales mode here, so apologize for that. Can't help myself. But we have plenty of time for a couple of deep dive on customer experiences. And I'm just going to borrow a couple of presentations from customers, and I'm going to therefore probably not do a great job presenting them, but I think together we walk through them, we'll get a good sense of a couple of good examples of what people are doing. So one customer we have that presented this presentation recently at a symposium that we held in Israel is MoveIt. And you can see that MoveIt's stated purpose is to revolutionize the way people experience public transit. And they're thinking about this problem globally. 7 billion people, sorry, it's chopped off there, 900 million cars. And transit, big portion of their life. So this was an example over time, over the last, as they began to ramp their applications. I think this is pretty much just about a 2-year period. And the number of users and devices that they were measuring, they went from, measured in the hundreds of thousands to up to 9 million now, in a very short amount of time. And this also shows the cities where their application is active and their smartphone apps and their sensors are out there doing things. They're getting sensor feeds from the local transportation companies or entities and so forth. Transportation, huge part of our life. These are some average commute times in different cities. Some are painfully long, some Los Angeles and New York City way up there on the international scale. Can be very frustrating. This is the experience we mostly have of public transportation. So what they're trying to do is change all this. They take data feeds from actual city data feeds about traffic and different kinds of things about the transportation networks. They get data feeds or help create data feeds from the buses and the trains and all the things that are actually moving around in the environment, moving people. And then, critically, they actually treat their users as sensor devices, right? Because you run the smartphone app, and with your permission, it's telling their system all about your behavior, how long you're waiting, where you are, how fast you're moving, all these kinds of things. So they build incredibly elaborate capability to actually understand and then gradually improve the experience of people with public transportation, including knowing when the bus is going to come, being free to go do that little extra shopping because you're not worried about missing the bus, all the way down to helping through feedback the cities and the planners to do improvements around really rich data and data analytics for exactly what's going on in these environments, something that the cities generally don't even know or haven't known historically with any level of detail. How many people use the MoveIt app? Anybody out there using it? There's another similar app for drivers, Waze. People use Waze. Yeah, okay, we got a lot of Waze users. Similar concept there, although it's a bit more American, individualistic, right? It's just the cars and Waze, and not that many others, data feeds and so forth, but I use it all the time. It's that's actually a really great example, too, of a sensor network that, through the feedback of the users and participation, the great network effects that come from that, you get really great data and great outcomes. So in this case, they provide smartphone apps that do just what you'd expect. give you a sense of where the buses are, what the trains are doing, where the crowds are, what the users are, what the delays are, what the times are, and choose the best navigation so you now can contribute, and effectively to the efficiency of the system, because you're now an intelligent participant in sort of this networked world where before you were, you had this very, very constrained view into what was going on in that environment. So quick facts about this customer of Amazon Web Services, world's #1 transit app, 23 languages, 40 countries, 400 cities, and about 50 million daily passenger reports. So pretty incredible. It's a huge data management problem. A few more statistics. 5 million daily real-time requests, 50 million reports. Their daily usage over 650,000 users, monthly usage over close to 3 million, 1.9 million daily sessions, and growing very rapidly. So, what do they use from the Amazon stack? They use a lot of our services. The EC2 compute service, a managed SQL service we have called Relational Database Service. We have a very powerful NoSQL database called Amazon DynamoDB that they use, and a bunch of other things. I won't go into all the details, but the point is they're using a variety of cloud services to build and power this really powerful application. One more example, and then I'll have time for questions. Living Planet. Anybody heard of Living Planet? It's a UK-based organization doing some really interesting things with smart cities and industrial systems. Let's see if we can bring up an abbreviated version of one of their presentations that I will show here. So their slogan for this in this presentation, it's cut off there unfortunately, is Urban Environments and Edgeless Computing, the Internet of Things for Cities. Now, one reason I put this deck in here is, even I'm not going to read this text to you, and I'll send you a copy. We'll post it so people can download and read. But you can see that this is a company that's thinking about the policy problems. They're not just a technology company. They're thinking in terms of how can technology be applied to policy issues, human issues that face us all. So when they think about their business, these are the kinds of goals they're thinking about: eradication or alleviation of poverty, increasing educational outcomes, improving maternal health. These kinds of topics. This is how they conceive of the value prop that they provide through technology to work on these large-scale problems. Urbanization, continuing over human history for the last however many hundred years, increasing concentration of people in cities. May not be such a great idea, but it's happening, and it's probably a very perhaps unreversible trend. But that requires a lot more intelligence and a lot more effort to be put into building systems that support these highly concentrated human populations. So this is their business model, their business thinking. I'm just going to flip through this rapidly. So they have a white paper. This is a good one. So one of the things they point out is the construction industry. They call it construction source, so the people that build buildings. And they say, oh, look, a shooting star is this construction industry. And oops, disruptive technology. Their planet's about to be hit by an asteroid, and they want to be part of that, and they have this interesting graph which essentially looks at the productivity measures in different industries. So we have automotive, shipbuilding, aeronautics on the one hand. As you can see, step functions in productivity and value over time. And construction is that gray curve at the bottom, which is just hovering there, but basically not really advancing because it's never been able to take advantage of technology. So one of their business goals essentially is to make every building a smart building, right? Every city a smart city, so that the value, the feedback of the data, the kinds of, there's a skeleton within every structure that is a data structure and a value-driving thing which is based on the data that's being emitted and being gathered from within those environments. One more slide on the construction industry that they're very eager to help change. So the idea of internet will sense and act to all these different kinds of scenarios. Collaboration, today users, connected enterprise, and then millions, hundreds of millions, consumer goods and consumers, and then to objects, the internet connected objects into the billions and trillions. Everything collaborating. And this is their, again, I'm sorry, the top's cut off my slides here. Edgeless computing framework. This is kind of their, trademarked approach to this problem. I'll just flip through these really quickly. This is a report that you can download, which is exactly laying out their vision for how to tackle some of these very large problems, from power management, smart grid, water treatment, all these kinds of things, security and privacy, and these are problems that we as an industry have to solve together. This is their diagram of how to go about doing this, and then they have a much more detailed slide that I'm not going to show, which maps some of their product offerings into these different parts of this overall space of both business and technology. We are all becoming sensors, so smartphones also really begin to change the equation in terms of these social problems, because now you have the ability to programmably access. Again, there's huge data and privacy and security concerns there, but this is a tidal wave that's hitting us, and we need to get ahead of it, and we also need to take advantage of it and allow in a sane and safe way, in a way based on consent. We need to take advantage of the fact that our citizens now have the ability to gather and to inform policymakers about what's really going on in that environment. How many of you heard of the street bump application? You ever heard of street bump? So, a couple people. So, City of Boston, anybody knows City of Boston knows they've got a problem with potholes, right? I guess, in fact, I think that's I'm from California originally. I think they're called frost heaves would be a term that the Bostonians would use, or something like that. One of the problems they have is they don't really know how big the problem is or where the problem is. So they've struggled with not only a problem, but what is it and how do we prioritize it? So some very clever technology innovators in concert with the city planners came up with this idea. Hey, there's an accelerometer built into all the phones, so the phone can sense potholes, right? If it's sitting in your car, even if it's in your pocket, it's going to get a jolt periodically. So if you can just get people to run in the background this little application as you drive that's measuring jolts, and if you correlate those jolts, right? Because now you've got the GPS location, you've got the jolt, the acceleration. Now you've got a classic big data problem. Tons of data. It's probably got a lot of noise, because sometimes the jolt is when some kid slaps another kid or whatever. Fine, that's not an issue. You got to get rid of the noise. Where's the signal in all that? And the signal comes from when you get very large data sets. It's extremely unlikely that the same kids are slapping each other at the same place on the same road every day. It's in high volume, right? So those are potholes. So now the city has a very, very good understanding of where the potholes are and the ones that affect their citizens the most. That's the other thing that's really interesting. If you just kind of drive down the street looking for potholes, you're going to see like 20 big ones, right? But which are the worst? It's not the size, it's the number of people impacted. So this kind of tool enables very interesting and intelligent addition to the toolkit. Now, you still have to have a crew to go fix the potholes, so it doesn't like magically solve some of the problems the government faces, but it does help. And as we grow more and more sensors, these problems will just, the capabilities we have will just grow and increase. If we're smart about it, we as an industry and as a policy community can make progress. So this is the last slide I'll show from Living Planet. They call this the Urban App Store. They want to literally develop, downloadable code and capabilities and platforms that people can just sort of install in their environment and run to work on these core problems, whether it's well-being and health, environmental monitoring, water treatment. Let's, as an industry, develop the standards and the technologies that enable these problems to be dealt with using these technologies that we have. So some other things you would have thought about: vehicle intelligence, child mortality, reducing that through technology. There's a great story there. Another cloud computing success story of a pediatrician in Toronto who worked with premature babies, and they have all these health problems. Sometimes they come on kind of mysteriously, and of course the slower you are to recognize the problems, the more risky they are. She had the really smart idea, which is why don't we take, and they have a lot of telemetry, right? They have temperature, heart rates, because they're often sitting in well-instrumented cribs in the NICU. But it's human input, right? Someone walks by and looks at those readouts, right? There's no way to apply some of the machine learning type techniques to it. So that was her insight, was let's take the data, feed it into machine learning systems, and try to see if we can correlate historically. Yeah, this child had a really bad event, and what was happening 24 hours before, or 12 hours before in terms of this monitoring data that we have, but wasn't enough to alert the nurses or the caregivers to do something. Sure enough, she found lots of strong signals. Once she knew that, she could put now a different kind of instrumentation in places. Like when you see this type of correlation, which it's not noticeable to a human, but when the certain patterns arise, whether it's heart rate or temperature, all these kinds of things that they have, the automated system can say, hey, there's a pretty good chance this baby's going to have an event in the next 24 hours because it's all happened historically. There's a lot of so the thing that's so interesting about these data problems is you don't have to think about causation. I mean, it's kind of, it's almost an interesting sort of philosophical question going back to David Hume for you philosopher types, the argument whether there are such things as causes or whether it's all really just, human perception of regularity of happenings. I happen to be a non-human and I'm an Aristotelian, but nevertheless, the thing that's interesting about this particular problem is, even as an Aristotelian, I'm perfectly happy to give up the search for causes because the correlations are so valuable. It's incredibly valuable to know that 90% of the times these things happen, in this amount of time, this thing happens. Why? No idea. But it's really, really useful to know. And then to do something in advance or what have you to try to deal with that and intervene. Super valuable. So I'll finish the sales pitch from our partner Living Planet, who, of course, uses Amazon Web Services. And I think I've still got about 5 minutes here. So I will use their thank you slide. Actually, I think I have my own here. Thank you for your time, and I'll hang around for a little while, so to take any questions you may have. Thanks very much.
Thank you. Just a reminder, if you want any of these slides to look at them later about the 6 or 7 reasons why it might be smarter to go secure via cloud, they're available at tech.state.gov. We do have time for a few more questions. So do we have any questions? Anyone? Okay, well, you can always reach him after this. Oh, sorry, we have somebody. All right.
I work in the in disaster field with emergency managers, and one of the problems that we've seen is that they may be running a localized web EOC service. And I've kind of come to this conclusion that our cloud providers such as yourself are in the same position that early television stations are, in that they need to perform a function to help society. And I think that coming up with a public service cloud or something like that, the local emergency managers can hybrid it up or spin up.
Yep.
If Anacostia is destroyed, DC will lose any emergency capability.
Right.
So we need, I think, the cloud service providers to have part of their stack that can be spun up.
That's a great point, and we do a lot of that already, actually. Some of it literally for free. We have, not specifically for disaster recovery yet, but we do have a lot of things we call public data sets where we host for free important data that people can get access to and update, and working with data curators to update that regularly. So, for example, we have something called the 1,000 Genomes Project that is essentially a free access to a very important NIH database that they're updating frequently. They have a lot of collaborators. The number of collaborators jumped dramatically once they put it in the cloud because it was really difficult to get access to this before. It's about 350 terabytes and growing pretty rapidly. And just getting the physical, hard disk shipped around kind of thing was really constraining the number of collaborators. Now they've got hundreds. Before they had, like less than 20. So that's an example from medical research of essentially a public hosted capability. Specific examples in disasters. So, for example, in Hurricane Sandy scenarios, there were we partnered, one of our major partners in this sort of geospatial areas, Esri, the company ESRI, and they stood up an entire response system on our cloud to specifically deal with Hurricane Sandy. I don't think they charge anything for it. So. And similar things happen with the oil spill in the Gulf with systems that were stood up in a matter of days or less than a day, cloud hosted. But it's a great point, and it's something we're actually very eager to work with people to figure out. We do a lot of research grants. We give away a lot of free compute to researchers, and we would certainly consider doing some kind of collaboration around disaster recovery, essentially as part of our community outreach.
Thank you. You featured a number of interesting applications, sensory applications. So I wrote some of them down, but do you have a catalog, an online catalog of the companies you provide services for so that people can go exploring? Because otherwise, I'm hunting across the internet.
Yeah.
I mean, I'm Googling it, but
That's
if
a
the
that's
cloud
a great
service
question.
providers-
We do have there's a part of our website which is devoted to case studies, and those are places where we have, with the customer's permission, we've done a public write-up of what they do. Now, we also, though, are very careful about customer privacy or customer control. So, we have a lot of customers that don't like to talk about how they build their systems or where they run and so forth. And so we, of course, honor that. So there's, a lot more that we could talk about if we had permission. But many that do cooperate. So could be a starting place to kind of look in our case studies, and there's some filters you can apply, like different types of applications, different types of uses. It's probably not, maybe as comprehensive as you or I would like, but maybe we could talk offline and we could think of some ways to build more of a kind of curated set of the kinds of systems that we were talking about today. It'd be an interesting thing to do.
All right. Well,
Thanks very much.
Thank you. Let's give him a round of applause.